So for question number 12, we're being asked to convert between the two different forms of a log form or an exponential. Remember that these forms are, that the log is the inverse of the exponential and the exponential is the inverse of the log, so they go back and forth. This is something I referred to earlier as the log dance. To go from log form to exponential, the dance includes, there are two items, the base and the input on the one side. When we go to the inverse, these two are going to split sides of the equal sign, right? So the base remains the base, and it's going to join with the output. Remember, so what happens is for the log form, the 125 is the input, the x is the output. An inverse function switches the input and the output. So the x is now going to be the input for the exponential form. The 125 will be the output. So that's what I call sort of the log dance. It's just a matter of reorganizing it, because that's what an inverse function does. It takes x and y and makes it y and x. Okay, so let's go back the other way. Same thing with an exponential. We have a base, and that's the thing we can always focus on. So for a logarithm, the base of the logarithm will be the same as the base of the exponential. So this becomes log base 2. And then what we can see is that the 2 and the x are not going to be together, because an exponential function sort of breaks those apart. So what has to go into the logarithm? Well, it's the answer. The output is 64, so that now becomes the input to the logarithm. The input, which was the x, the exponent, becomes the answer to the logarithm. And we just keep going. Here's a base, and it's going to have a exponent of -3. So we get 2 to the -3 equals x. So this is, in this form that we're seeing, we have actually solved for x simply by doing what I call the log dance, reorganizing it 2 to the -3. We could actually calculate this now, right? 2 to the -3 is ends up being 1 over 8, because it's got the negative exponents. 1 over 2 to the third. 2 to the third is 8. Okay, so we have actually solved for x. Now sometimes these other ones, they're starting with having already solved for x. So what would the logarithm look like? Again, we focus, here is the base of the exponential. So that's going to become the base of the logarithm. And then what's going to be the input into the logarithm? Well, it's the answer, or the output. And then what was the input in an exponential function is now the output of a logarithm function. So that is question 12, being able to convert back and forth.